Welcome to Assessment 1 of Software Engineering. Here in this video, we will explore how DevOps has evolved from Agile methodology to continuous delivery and how cloud-native environments are transforming modern software development. This is Abba Matthews along with my team members Zahid, Rohit and Tony. DevOps combines development and operations, enhancing automation, collaboration and continuous integration. It allows organizations to release software faster with fewer failures and with greater reliability. Why do you think DevOps is crucial today? It's because it speeds up the release cycle, improves system stability, and fosters better collaboration between teams. Research shows that organizations using DevOps have increased the deployment frequency by 46% while reducing the failures. DevOps is built upon Agile methodology, which promote flexibility and integrate development. Continuous delivery ensures that software is always ready for deployment. DevOps extends these principles by integrating automation, monitoring, and collaboration for seamless software delivery. It is very clear that with the rise of cloud computing, DevOps has evolved further. Cloud-native environments leverage technologies like containers, microservices, and Kubernetes to enable greater scalability, flexibility, and automation. Cloud-native DevOps take efficiency to next level by automating infrastructure, improving deployment speeds, and reducing operational cost, leading cloud providers like AWS, Azure, Google Cloud empower organizations to achieve up to 60% better scalability and efficiency. So far, we have covered DevOps evolution from Agile to continuous delivery and its impact on modern development with cloud-native technology.
Today, I'm going to discuss about the significance of DevOps in today's software development landscape. Let's first look at how it evolves over time and the key role cloud-native environments now play in shaping DevOps practices. As far as the historical development of DevOps is concerned, the traditional approach to software development known as waterfall was slow and linear, where each phase had to be completed before the next one could begin. This created long feedback cycles and delayed releases. With the advent of agile methodologies, there was a shift towards iterative development and faster releases. Teams work in shorter sprints, enabling quicker iteration, but Agile alone couldn't meet the growing demand for faster and more efficient software delivery. With the entering of DevOps, which broke down the silos between the development and operations teams, DevOps focused on automation, continuous integration, and collaboration, enabling teams to deliver software more reliably and efficiently. It was born out of the need to bridge the gap between development and operations, driving a culture of continuous improvement. With the transition from Agile to DevOps, as Agile improved development speeds, the needs for continuous integration (CI) and continuous delivery (CD) grew. DevOps became the natural evolution of Agile because it integrates these practices. CI/CD pipelines allow code changes to be tested and deployed automatically, drastically reducing manual intervention and speeding up the release cycle. This tradition made it easier for organizations to deploy new features, patches, and updates faster and more efficiently. With the adoption of cloud-native technologies, the rise of cloud computing, organizations began adopting cloud-native technologies to support their DevOps initiatives. These technologies include container, which is a lightweight, portable environments that allow developers to build and run applications in isolated environments, ensuring consistency across different stages of development. The next one is Kubernetes, an open source platform that automates the deployment, scaling, and management of containerized applications. And the third one is microservices. It architects that break down applications into small independent services, each running in its own container. This allows for faster development and more scalable applications. Cloud-native environments have become integral to DevOps as they enable better scalability, flexibility, and easier deployment of application. The next part is methodology. If we talk about the introduction to research methodologies, it is defined as when studying the evolution of DevOps and its impact on software development, researchers employ both qualitative and quantitative methods to gather insight. Let's take a look at both. In qualitative research, interviews, case studies, and observations are conducted with professionals in the field. These methods provide in-depth insight into the challenges and successes organizations face during the DevOps transformations. Researchers may also explore how DevOps practices are adopted in different industries or regions. In quantitative approach, on the other hand, uses numerical data such as surveys or performance metrics to ensure the effectiveness of DevOps practices. For example, researchers might track the time it takes to release software or measure the frequency of production error before and after adopting DevOps practices. These studies help build a data-driven understanding of how DevOps impacts development efficiency. There are several tools and platforms that are commonly studied in DevOps research and practice include Docker, which is used for creating, deploying, and running applications in containers. And the next one is Kubernetes. It manages containerized application in a clustered environment, ensuring scalability and availability. And if we talk about the cloud, so it includes AWS, Azure, and Google Cloud. So these cloud platforms support automation and scalability needed for DevOps workflows, providing infrastructure as a service for DevOps teams.
Hi, hello, myself Tony K. Sebastian. I am here to explain the findings in the evolution of DevOps and continuous delivery. Imagine a world where software updates happen instantly without downtime, without errors. This is no longer a dream, it's a reality driven by DevOps and continuous delivery. But how do they actually impact organizations, especially in today's cloud-native world? Let's explore some fascinating insights. Yes, DevOps is reshaping deployment speed. In 2011, Amazon engineers deployed software every 11.7 seconds. Today, companies like Netflix and Google have refined DevOps practice to an extent where they release thousands of updates per day with near zero failures. This is only possible because of continuous delivery, which automates every stages from code commit to production deployment. But what's changing in 2025? Under AI-driven DevOps, where machine learning model predict deployment failures before they even happens, Google's Dora metrics now use AI to analyze DevOps performance, helping team improve deployment frequency and reduce mean time to recovery. Today, over 75% of global enterprises are using Kubernetes to manage containerized applications. Why? Because cloud-native DevOps is solving the biggest challenges in modern software deployment: scalability. Take Tesla, for example. Its over-the-air updates to millions of vehicles are powered by Kubernetes-based DevOps pipelines, ensuring cars receive real-time bug fixes and performance enhancements. Another breakthrough is Edge DevOps, where updates are no longer come from centralized cloud servers. Companies like Cloudflare and Version are deploying code at the edge of the networks, reducing latency from seconds to milliseconds, making application 10x faster. The next evolution of DevOps is GitOps, where infrastructure is managed as code through Git repositories. Spotify, for instance, now uses Argo CD and Flux for automated deployments, eliminating human interventions and reducing configuration drift. This approach is revolutionizing self-healing infrastructure in cloud-native environment. Even platform engineering is gaining traction, offering internal developer platforms that abstract away DevOps complexities. Imagine a developer pushing a button and deploying an application without worrying about Kubernetes configurations. That's where DevOps is heading. So, what do these findings tell us? DevOps is no longer just about automations. It's about intelligence, speed, and adaptability. With AI-driven DevOps, edge computing, and GitOps leading the way, the next decade will be about self-learning, self-healing software that deploys itself with zero downtime. The future of DevOps is here, and it's evolving faster than ever.
Hi, it's me Rohit. Let's talk about something that's reshaping the way software is built and delivered: DevOps. Agile has helped teams develop software faster, but DevOps takes this a step further by integrating development and operations for seamless automation, continuous delivery, and improved reliability. Sounds great, right? But here's the catch. Shifting from Agile to DevOps isn't as simple as flipping a switch. It comes with challenges, and today we will explore 3 major roadblocks organizations face and how they can overcome them. Change is hard, and for many teams, moving to DevOps feels like stepping into the unknown. Agile teams are used to working in silos. Developers focus on coding while operations handle deployment. Breaking this structure can create pushback. Some fear automation will replace their jobs, while others resist learning new tools and processes. And if leadership isn't fully on board, well, the transition can stall before it begins. So how do we fix this? Simple. Create a culture of collaboration. Show teams how automation makes their jobs easier, not harder. And most importantly, leadership must champion DevOps, providing clear direction and support to drive change. Okay, let's say teams are open to DevOps. Now they need the right skills to make it work. DevOps isn't just about writing code, it's about automation, infrastructure as code, and integrating security from the start. But many agile teams lack experience with tools like Jenkins, Kubernetes, and Terraform. So what's the solution for this? So the solution for this is to invest in learning. Organizations must provide training, encourage certifications, and even hire DevOps specialists to mentor existing teams. The more skilled the workforce, the smoother the transition. Now let's talk about the tech side of things. Even if teams and leadership are on board, outdated infrastructure can slow everything down. Many companies still rely on legacy systems that don't support automation or cloud computing. Plus, agile tools may not integrate well with DevOps pipelines, making the transition even trickier. And then there's security. Rapid deployments mean security teams must work faster, but without the right processes, vulnerabilities can slip through. So the fix for this is a step-by-step approach. Organizations should modernize their infrastructure gradually, implement DevSecOps to build security into the pipeline, and streamline tools to create a unified development workflow. Cloud-native DevOps challenges. With cloud-native DevOps, security is a big concern. With more services and more deployment leads to more chances for cyber threats. Misconfigured settings, exposed APIs, and weak authentication can leave systems vulnerable. The solution is to build strong security policies, automated checks, and a zero-trust approach to protect data at every step. Relying on a single cloud provider can be risky. What if price goes up? What if they change their services? Moving everything to a new provider can be expensive and complicated. The best way to avoid this is to use multiple cloud platforms and open source tools to keep your options open. Cloud-native DevOps isn't just about writing code, it's about managing a complex system. Containers, Kubernetes, microservices, it can get overwhelming. Without the right tools, performance issues and insufficiencies pop up. The solution is to use automation, monitoring, and infrastructure as code to keep things running smoothly.
DevOps has evolved from agile to continuous delivery and now cloud-native environments. This shift enables faster release, better collaborations and automation, reducing errors, downtime while improving efficiency. The future of DevOps is AI-driven automation, smart monitoring, and self-healing system. Infrastructure as code ensures scalability, cloud deployments, while DevSecOps integrates security into every stage, making DevOps more secure and efficient. As we look ahead, DevOps will continue to revolutionize software development. AI, automation, and cloud-native approaches will define the future of IT. As the famous saying goes, DevOps is the future of software development. Companies that adapt these advancements will have a competitive advantage, delivering faster software more securely and with more flexibility. DevOps is no longer just a practice, it's essential for staying ahead in today's digital world. Thank you for watching.